This is part 3 of the chapter 18 flip. I apologize for the abrupt ending to the last video. I didn't realize I was running up against my time limit. Just a few slides to summarize here to sort of wrap things up. The multi-step hypothesis says that we need several things to break. Our body has a lot of control mechanisms in place, so a lot of things have to go wrong before cancer develops and things become really, really dangerous. So let's look at colorectal cancer specifically. The far left side there, you see normal colon epithelial cells. If we acquire a mutation, we lose a suppressor gene. We get a benign polyp, benign growth. If you're following your doctor's orders and getting a colonoscopy at the appropriate times and with the appropriate frequency, you can catch these polyps and you can have them removed, and you likely never develop an adenoma or a carcinoma or a tumor. But if you don't follow the doctor's orders or you're not getting frequent checks, you can accumulate more mutations that can lead to a larger benign growth, but it's still benign, so it's not the worst thing that's ever happened. If you catch it at this stage, you can remove it and likely you won't develop cancer. But if you still aren't receiving treatments and you aren't being checked and you receive one or maybe two more mutations, that's where things become bad and they can break off and metastasize and move around to other parts of the body. So it takes multiple steps to receive or to develop cancer, usually. But sometimes, if you're exposed to extreme radiation or there's some large trauma that damages a chromosome, you can shortcut and you can get more of those mutations all at once. If you're in a nuclear meltdown and you're exposed to large doses of radiation, well, large doses are going to be fatal, but relatively large doses of radiation, you can acquire all 5 mutations all at the same time. Like I said earlier, there are proto-oncogenes that are inherited. Like this sort of gets back to what I said earlier. It puts you closer to developing cancer than someone who doesn't have that proto-oncogene. Kind of the most famous example is BRCA1. BRCA1, if you have the normal version of BRCA1, you only have a 2% risk of developing breast cancer in your life. If you have the abnormal version, you have a 60% risk. Of course, it's genetic. It's going to be inherited through Mendelian inheritance patterns. Some folks that have the BRCA1 mutation will preventatively have mastectomies so that they don't have that cancer risk. It's sort of an extreme measure, but they've got a 60% chance. They got a better than 50% chance of developing cancer. So they take those extreme measures to not have to go through chemo and radiation and some of those awful things that you have to go through when you develop cancer. So again, they're proto-oncogenes that just you're closer to developing that type of cancer. So to summarize, we need to know the operons. I can't emphasize those two, lac and trip, enough. Please make sure you understand those. We need to be able to discuss each of the control mechanisms. You need to explain how, where, when, what happens as a result of each of those control mechanisms. Be familiar enough to talk about development of the organism, things like bicoid and the Hox genes and the homeobox genes and all that kind of stuff. And then last but not least, the cancer stuff. So that's the end of chapter 18. Come ready with questions on debrief day.